Hey everyone! Today I'm showing you how Blender can handle precision hard surface modeling. I recreated a mechanical part entirely in Blender, and you'll see it can match CAD level detail. This is the reference drawing we will model. Our main focus is precision CAD based modeling without using extra add-in. So without delay, let's begin modeling. Delete these lights and camera for now, and let's set up our scene measurement from meter to millimeter. Here we add the reference image. Add the circle and adjust its diameter and rotation. Before we go deeper, let me know in the comments, are you using Blender for hard surface work, or do you still rely on CAD software? Add the single vertex. This will help us guide for the right measurement and also make it easy to use for snapping. Extrude 24 mm, then 20 mm after that 38 and so on. You can guys calculate the distance between the edge. We can see our edge length, and to do so, click here and check on. Extrude 12 mm on Z-axis. I started with the main form using simple shapes and correct proportions. Instead of rushing details, I focused on getting the base structure right. This step is important because clean foundations make precision work much easier later. I'm just extruding these edges after doing some calculation to make ours work easier and faster. And this model will be ready for 3D printing also. This is our foundation only for snapping purpose. Let's move this for now and work on ours real model. Extrude on X-axis and straight this curve edge by pressing S plus X plus 0. While selecting the edge, press GX and Control button for snapping. This way we don't need to see ours edge length and adjust measurement because we already set the dimension ready in ours vortex foundation. For precision, I relied on snapping, measurements, and consistent spacing. The idea is not to overcomplicate the model, but also not to guess. Clean topology helps the model stay accurate and makes it suitable for rendering or 3D printing. I use common hard surface techniques like edge control and booleans where needed. Everything is placed carefully to keep the model sharp without making the topology messy. By the way, if you're enjoying this video so far, consider subscribing to the channel. It really helps a lot. And let me know in the comments which mechanical part or model you want me to create next in Blender. If you notice any red faces, it means the normals are facing the wrong direction. This helps identify flipped normals or internal faces that can cause problems later. This step is very important for clean shading, accurate renders, and especially if you plan to export the model for 3D printing or manufacturing. And here's the final result. The model is fully complete with clean topology, correct normals, and simple textures to clearly show the form. This workflow keeps things precise without making it overly complex, and it shows that Blender works very well for hard surface mechanical modeling. If you found this helpful, like the video and subscribe for more Blender precision tutorials. Also comment below which mechanical part you want me to model next.